name's Dan Hagen, and the goal of this work is to examine the relationship between sediment erosion or scour and catastrophic bridge failure. So basically what we do is we boil down a turbulent flow to the fundamentals. In this case, it's a vortex dipole, which is just two counter-rotating vortices, which can be found in not only turbulent flow, but also flow past fluff bodies or objects or even a rough surface. And what we do is we take a sediment bed, implement our flow structure, let it propagate downwards. You can see here, it impacts the bed and erodes the bed. And we let the dipole or the vortices dissipate, and we let all the particles settle, and we look at the topography and the scour hole depth. So once we have that first impact, we actually reintroduce another structure, let it impact again, let the whole thing happen again, and do that for a third time. And we do that for a range of flow intensities. And what we found is that for the lowest of our intensities, we find that by the third impact, we're already seeing an asymptotic limit form in terms of the scour hole depth. So you can see these are the depths of the first, second, and third impacts. And for our lowest intensities, they basically level off by the third impact. But in our fourth intensity, we see that we actually have an increase, a nonlinear increase in the depth. And we're pretty sure that that's due to how deep the hole gets due to the first couple impacts. And we have these mounds that form. You can see them here as well, but they're exaggerated here. And you can see how much larger they are than in the previous. And what happens is, rather than the two vortices after they impact separating, they're actually forced back together by these mounds, so they can't crest the peaks. So it reforms, and we have a now lower intensity, albeit, but a reformed dipole that repropagates again and impacts the bed, and that's how we end up with this nonlinear increase. And you can see that here as well. Rather than separating, the actual path of the vortex actually comes back to the center. So what we're hoping to do with this work is eventually get to the point where we can say existing scour after a big extreme weather event, maybe at a bridge abutment or something like that, we can go and say, all right, do some sort of measurement and say it's in this regime where we don't need to do any more, we don't need to repair the scour because it's achieved a sort of asymptotic limit, or it's beyond that and we do indeed need to spend some money and try and improve that situation.